Good morning, students. Today we are going to study about common base configuration. So a common base configuration is generally the common bases are also called as ground base. The base terminal is common to both input and output. Here the input voltage is applied between emitter and base so that the output voltage is taken between collector and base. So we are giving the input current through emitter current and we are collecting the output current through collector current. And this is the circuit diagram for common base configuration, and this is the NPN configuration and this is the PNP configuration. See the arrow mark. When the arrow mark is outward, the transistor is called as the NPN transistor, and when the arrow mark is inward, then it is called as the PNP transistor. So here, see here, the terminal, base terminal is common to both input as well as the output in both NPN and PNP configuration. So this is the input emitter terminal and the collector terminal is the used for the output. So next we are going to see about the current amplification factor alpha. So it is defined as a ratio of change in the collector current to the change in the emitter current, that is delta IC divided by delta IE, where IC represents the collector current and IE represents the emitter current, and the voltage, that is the voltage across collector base configuration, is constant. So this alpha is called as the current amplification factor. So alpha is also called as the characteristics, that is alpha is also called as the current amplification factor, and it is the ratio of output current to the input current. It is always less than unity. It can be increased, that is we can increase the value of alpha by decreasing the current across the base. So actually for achieving this, we are making the base of the transistor very thin, and while doping it should be lightly doped. So generally the value of alpha ranges from 0.9 to 0.99. Next, expression for collector current. So collector current is represented by the symbol IC, which is equal to alpha IE plus the leakage current I leakage. So if the emitter base voltage VEB, that is voltage across the emitter base, is equal to 0, then a very small leakage current flows in the circuit. So it is termed as the ICBO, that is collector base current with output open. So therefore, the collector current can be expressed as it is the sum of alpha IE. Alpha is the current amplification factor, I is the emitter current, and the leakage current across the collector base terminal. So next we know that the general equation is the current across emitter is equal to the sum of current across the collector and base. So IC is equal to alpha of IC plus IB plus ICBO. So we are multiplying the alpha inside. So we got an equation like this. Then bring this alpha IC to that side. So IC minus alpha IC is equal to alpha IB plus ICBO. So here IC is common, take it out. So 1 minus alpha is equal to alpha IB plus ICBO. So finally we are getting IC is equal to alpha divided by 1 minus alpha into IB plus ICBO divided by 1 minus alpha. Just we are bringing this 1 minus alpha to this side. So dividing separately with the numerator, we are getting the equation. So the characteristics of common base configuration is, so Ri is equal to voltage across the emitter base divided by the current across the emitter at VCB, at constant VCB. And the RO, the output resistance, is represented by delta VCB divided by delta IC, where the input current across the emitter is constant. So active region, IE is increased. When the input current increased, the output current is decreased. And BE junction, as base emitter junction, is always forward bias, and common base junction is reverse bias. And when you refer the graph, IC is approximately equal to IE, and the output, that is output current, is not depends on the voltage across collector base terminal. Suitable region for the transistor working as an amplifier. So we can use this region for working as an amplifier. Saturation region. So here base emitter junction and common collector base junction is a forward bias. So very small changes in the voltage across collector base will cause big difference to IC, collector current. So the allocation for this region is to the left of VCB, that is equal to 0 volt. Next, cutoff region. Cutoff region below IE is equal to 0 amperes. So here base emitter and collector base junction is reverse bias. No current flow at collector, only the leakage current. Thank you.